Hello guys, this is me, your electrical Guruji, welcomes you all in this new session in the power electronics series, that is our buck converter. So what is actually a buck converter? To know more about buck converter, please stay on this video till the end. Thank you. Let's see what is buck converter. Buck converter is a DC to DC power converter which steps down the voltage from input to its output. Huh? Is it isn't it just like a step down chopper? Yes, but there is a difference between step down chopper and buck converter, and that is its output. In chopper, the output is in the step format, while in the buck converter, smooth continuous DC will be the output. And how can we achieve this smooth DC output voltage? With the help of capacitor. Now what are the applications of buck converter? Applications are like you can control DC motor with the help of buck converter, solar energy systems, then wind energy systems, battery charging, and many more. And for low power applications, the power devices which we are going to use are like GTO, IGBT, power BGT, power MOSFET, etc. And for high power application, we need to use thyristors and SCR. Now, how is the circuitry and working of buck converter? Let's see. The buck converter circuit is shown here. Now, in the buck converter circuit, if you can see, the buck converter circuit is just like a step down chopper. The difference is only this capacitor. This capacitor is there for the smooth output DC voltage. Now we'll see how it works. So this is the output waveform, which is again similar to step down chopper. Now let's see how it works when the switch gets closed. Once the switch gets closed, in that case the inductor will start to charge, and whatever is the input voltage appears across the output voltage. Meanwhile, the voltage will get stored in the inductor and the capacitor. When we just open the switch, in that case the stored voltage or the stored current in the inductor will start to discharge through the load. Now during this process, this capacitor again will maintain the output voltage because of the property of capacitor are mostly used to balance the voltage, as they stores the voltage and they opposes the change in voltage, so they'll try our voltage to remain constant at the output side, and the current will flow through the inductor to resistor via this freewheeling diode. Now let's analyze the output voltage equation. So output voltage equation is just like a step down chopper where the total time period is 1 upon t, and we are going to integrate from 0 to t on period V in. During this, if we solve this, the relation between the input and output voltage is D times of input voltage. And what is this D? D is the duty ratio. Duty ratio is equal to T on divided by total time. Now let's analyze the current. Now we have two different states. One is on state and one is off state. In both the states, different current can be observed. During on state, charging of inductor takes place, which gives you a rising slope of current, while in the next step where the switch is open, your inductor starts to discharge, which gives you a falling slope of the current. Now let's analyze. During this on state, the output voltage is the addition of input voltage and inductive voltage, so that we can find the inductive voltage is the subtraction of input voltage and output voltage, while there is no input voltage in the off state. So whatever output voltage will be equal to your inductive voltage, and the total energy stored in the inductor is 1 upon 2 L into I square. Now let's analyze the on state. The total time for on is from 0 to t on. During this, let's integrate the IL, and we all know what is IL. IL is VL upon L. And we have already seen what is this VL. VL is equal to VI minus V output. So if we just put this value, what do we get? I on is equal to Vi minus V output divided by L into T on. Now if you just recall all the previous knowledge, duty ratio is equal to T on divided by T. So if you can further solve this, you can get I on is equal to Vi minus V out divided by L into D into T. Here T is the total time period. Similarly, we can analyze the off state where the total load current is IL and the integration is from 0 to T off period because we are only considering T off state here. Now IL is equal to VL upon L where VL is equal to V output for the off state. So that's why ion is equal to V output divided by L. Now if you just recall the previous knowledge, T off is equal to capital T minus T on because total time period is the addition of T on and T off. So if you can further solve this, you get the I on which is equal to V output divided by L 1 minus duty into T. So these are the current equation for buck converter. So what is the summary which we have seen? What is the buck converter? Buck converter is the converter which steps down the voltage. And what are the applications? You can use it for controlling DC motors, for solar system, wind system, wherever DC supply is required, you can use this. V output is equal to D into V source, that is V input. I on for on state and I on for off state. I hope you like the video. If you like the video, please do subscribe the channel and thank you very much. This is the corona period, so stay home, stay safe and fight corona by staying in your homes.